ISO IEC 42001 Annex controls are more than audit language. For architects, they are design signals. In this topic, we'll translate governance intent into AI system capabilities, implementation controls, and evidence that can stand up in certification. So far, we've moved from the purpose of ISO IEC 1421 to the ISO management system structure, and then to aim, scope, and inventory. Now we shift from what is in scope to what the controls require, preparing for the governance, risk, compliance, and impact assessment work in Module 2. Annex controls are where ISO IEC 42001 becomes practical for architects. The management system sets expectations, govern AI responsibly, manage risk, produce evidence, and improve over time. Controls turn those expectations into design choices, such as platform capabilities, approval workflows, monitoring hooks, model lifecycle gates, logging, and assurance records. The point is not to treat each control as an isolated checklist item. It is to embed controls into how AI systems are designed, built, deployed, tested, and governed. Done well, audit readiness becomes a byproduct of repeatable engineering practice. At a high level, ISO 42001 controls form a set of governance themes around the AI system. Policy sets direction. Roles define accountability. Risk management and impact assessment identify what can go wrong and who may be affected. Data governance and lifecycle management shape how systems are built, changed, and retired. Third-party oversight extends control to suppliers and integrations. Monitoring and reporting close the loop. For architects, these themes become work streams: platform capabilities, approval gates, logs, access controls, model operations, vendor controls, and evidence that the AI management system is working. I policy becomes useful only when it changes how systems are built and operated. It sets boundaries for model choices, data use, explainability, and when a human must review a decision. Governance turns those boundaries into approvals, exception paths, escalation steps, and decision records. Architecture makes them enforceable through access controls, configuration standards, guardrails, automated checks, and policy as code. Evidence then closes the loop. Model cards, approval records, audit logs, and control results show that governance is operational, not just written down. Accountability in AI governance has to be engineered, not assumed. Each lifecycle stage needs a named role with the authority to act and the obligation to answer for outcomes. The system owner may accept overall business risk, while model, data, security, compliance, and operations roles control their domains. The important step is mapping decision rights before work begins. Who can approve data, release a model, override a control, or retire a system? Architecture should enforce that map through access control, segregation of duties, workflow approvals, and traceable records. Without this clarity, audits find gaps, and incidents become finger-pointing. Risk management becomes architectural when each risk is turned into an explicit design decision. Start by naming the AI risk: bias, privacy leakage, model drift, hallucination, unsafe automation, or weakened human oversight. Then assess impact and likelihood so the response is proportionate. Treatment may mean avoiding the feature, mitigating the risk, transferring responsibility, accepting a documented residual risk, or requiring stronger assurance. The translation matters most. Risks become controls, such as validation pipelines, prompt filters, safety classifiers, access restrictions, fallback paths, and monitoring alerts. From there, maintain traceability from risk statement to tests, evidence, and live metrics. Impact assessment connects stakeholder effects to architecture decisions. Before deployment, teams should ask who may benefit, who may be harmed, and who needs a voice in oversight. Those answers should not stay in a policy document. They should become concrete requirements: transparency for users, explanations for affected people, appeal paths, monitoring, human review, and evidence for auditors or regulators. For high-impact use cases, the bar rises. Approval workflows, testing, documentation, and assurance need to be stronger. And assessment is not one time. Revisit it whenever the data, model, context, or exposed stakeholders change. Data governance has to travel with the data, not appear only at deployment. Start by confirming where data came from, whether its use is authorized, and whether it represents the population and purpose of the system. As data moves through preparation, labeling, training, validation, testing, and production, apply lineage tracking, quality checks, privacy controls, and access restrictions. Treat each dataset separately because training data, feedback data, and monitoring data create different risks. Evidence matters here as well. Inventories, approval records, quality reports, access reviews, and audit logs show that governance actually happened. Lifecycle controls make AI governance continuous, not a final checkpoint. An idea should move through concept, design, build, validation, deployment, operation, and eventual change or retirement with clear gates between each step. Those gates define who approves progress, what evidence is required, and which risks must be resolved. The scope is broader than the model itself. It includes prompts, datasets, features, pipelines, APIs, infrastructure, and integrations. Strong lifecycle control also requires release criteria, rollback plans, monitoring, and retirement procedures, so experimentation does not quietly become unmanaged production exposure. AI systems rarely stand alone. They rely on model providers, data vendors, APIs, cloud services, MLOps tools, and outsourced partners. Each dependency introduces risk that must be governed before and after adoption. Controls begin with due diligence, then become contractual obligations, security requirements, service levels, incident notification, audit rights, and change management. Architects should document who owns each risk, which controls remain internal, and where supplier assurance is required. Evidence may come from assessments, model reports, security attestations, metrics, logs, and alerts. Every critical dependency also needs an exit strategy. After deployment, control shifts from approval to observation. Monitoring should show whether the AI is still performing well, whether data or behavior is drifting, whether bias indicators are changing, and whether security, incidents, feedback, or policy obligations are raising concerns. Good dashboards serve two audiences: engineers who need operational detail, and governance teams who need risk status and accountability. Predefined thresholds are essential. When a metric moves into amber or red, it should trigger investigation, rollback, retraining, escalation, or suspension. Improvement happens when those findings become corrective actions and design updates. A control is not ready for implementation until it has been translated into architecture. Start with the intent. What risk must be reduced, and what governance outcome must be proven. Then link that intent to concrete capabilities, such as a model registry, approval workflow, audit log, access control, or monitoring dashboard. Next, define the pattern, owner, evidence source, and metric. For example, model approval before production deployment may require a gated release workflow, named approvers, timestamped records, and a test confirming that no unapproved model can go live. Control applicability is not a checkbox exercise. Ask whether the control fits the AIM scope, the AI system type, the deployment context, the risk profile, legal duties, and any third-party dependencies. If it applies, show how it is implemented, who owns it, how it is tested, and where evidence is stored. If it does not apply, document a clear risk-based justification. The strongest implementations create a traceable chain from risk to control to design decision to evidence, and finally to review or audit. Annex controls are most useful when you translate them into architecture. Design requirements, operational safeguards, governance processes, and evidence. The core idea is traceability from risk, to control, to design decision, to proof. That mindset turns compliance into engineering practice. In Module 2, we build on this foundation with AI governance, risk, compliance architecture, impact assessment, and stakeholder analysis.